Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 3 for recurrent neural networks and long short-term memory networks. So we were analyzing the movie reviews but with the recurrent neural networks. So the difference was these RNNs and LSTMs contains some sort of memory which can be used to keep the context of the previous things. So you must have seen these chatbots that you are using like ChatGPT and others. They have some memory. So when you give next prompt, it will take some context from the previous prompt and then give the response. So they have some sort of memory in it. So in TensorFlow, recurrent neural networks and LSTM are available that you can use to do those kind of things. So I told you how this project was working, and now I will tell you how to visualize the result, how to see the accuracy and other things. For training the model, we will train the LSTM model for 5 epochs. What are epochs? They are the passes. So I have shown you in previous sessions how TensorFlow works by again and again processing the data. So the again and again thing in technical terms is called epochs in machine learning and TensorFlow. So LSTM model, we will be using 5 epochs for training with batch size of 64. We will also split 20% of training data into validation set to monitor the model's performance. So as you remember, always when we have some data set for the machine learning model, we will split it in 2 parts. So here we are we also split 20% of the training data into a validation set. So 20% will be used for validation set. This is what this means. I have even gave the each and argument details what they mean. So model.fit, this method is used to train the model on the training data. And what's the training data? X train and Y train. So what X train data will contain is, this is the input data for training. It's typically a NumPy array or a tensor of feature, and what we have here is y underscore train. This is the target or label data. So the final output, as you know, is called target or label data in technical terms. So corresponding to X underscore train, it contains the correct output for each input. Then comes the epochs. This indicates the number of times the training algorithm will work through the entire training dataset. In this case, the model will go through the dataset 5 times. This is what epoch 5 means. The model will go through the dataset 5 times. Batch underscore size 64. This sets the number of samples per gradient update. Instead of updating the model's parameter after seeing every single sample, model will update them after seeing 64 samples. So you can understand this as a batch. Instead of going one by one, it will create batches of 64 samples and pass them. So what will happen if you use batch? So larger batches size can lead to faster training. So why are we doing this? So if you want to control the time it takes for the training and for the accuracy, so you understand this. If you go slowly and with more data, your model will be better. So larger batch size can lead to faster training, but smaller batch size allows the model to generalize better. So this is the reason people take time to generate or create the models, so that they for the accuracy, and so mainly the accuracy they go for that. So if you can pass the batch size argument like this, batch size 64, this is what this means. Validation split, This specified that 20% of the training data will be set aside for validation during training. The model will check its performance on its validation set after each epoch to monitor overfitting or improvement in generalization. If you remember what overfitting is, at a certain time, after certain time, it will not be able to detect the patterns in the new data. This is what overfitting was. So history, what this argument, so what this we are storing the this into history variable. So the fit method returns a history object which stores the details of the training process, including metrics like loss and accuracy for both training and validation over epochs. You can access this information via history.history. So if you want to look for the metrics and all other things like loss and accuracy, all those things will be available in this history object. And where we are getting this from, this is from model.fit. So because we are training the model and we are passing the settings, for example, for this model. So this is how you can pass. I have mentioned each and every argument what it means. Okay, so the part comes for evaluating the model. So once training is complete, we will evaluate the model on the test set and generate a classification report. And I told you this classification report will be very important if you are doing work for any company or anyone, because they will want to know the efficiency of the model. This is not in the real world, this is not just you can just train the model and give the model files to anyone. You also have to give the documentation related to these kind of accuracy and other things. So remember this is again very important step whenever you train these kind of models. So test underscore loss, test underscore accuracy is equal to model dot evaluate. So all these things, what they mean, I have mentioned everything here. Okay, let's see the part for evaluating the model. So you have trained the model in this step. So evaluating the model. So once training is complete, we will evaluate the model on the test set and generate a classification report to measure the model's accuracy, precision, recall and F1 score. So if you remember, I have done this with almost all the previous projects: accuracy, precision, recall, F1 score, all those things. So I will tell you what this line means. So model.evaluate, this evaluates the trained model on the test data. It returns two values, test underscore loss. So when you evaluate, it will return two things. One is test underscore loss and one is test underscore accuracy. So test underscore loss, the loss on the test set; test accuracy, the accuracy of the model on the test set, which is how well the model predicts the correct labels. So this is test underscore accuracy, accuracy of the model on the test set, which is how well the model predicts the correct labels. What this means is, this prints the test accuracy in percentage format rounded to 2 decimal places. So whenever you have a situation where you have to round off the numbers, so nearest to 2 decimal places, this is how you can pass in Python. So what is this? Y predict model.predict x test more than 0.5 as type in 32. So what this means is, so model.predict x test, this generates predictions from the model for the test data set. If this is a binary classification problem, and in our case movie review can be positive or negative, so this is a binary classification task. So if this is a binary classification problem, the output is usually a probability, a value between 0 and 1, indicating the model's confidence that the input belongs to class 1. So model predicts what this means. What this means is, converts the predicted probabilities into binary classes. Predictions with a probability greater than read this, prediction with a probability greater than 0.5 are classified as 1, and below 0.5 classified as 0. So if you remember, in the previous session I created the sequential layering for the model. Let's see. Okay, so here as you can see, in the dense layer we have passed 1 here because we are dealing with the binary problem. So in the layer also we have to pass that we are using the binary, we are in the binary problem space. So what this as type int32 means is converts the boolean prediction true or false into integers 1 or 0. So we require the result in the form of integer int32. So this is what as type means. As you know, visualizing the things makes better sense. To better understanding training process, we can plot the training and validation accuracy or loss over epochs. So you can easily understand what this code is, but I have mentioned again here. So this retrieves the training accuracy values of each epoch. Training accuracy, this is how you can get. If you remember, you used dot fit there and stored in history variable, and you can read the accuracy like this, and you can read the val underscore accuracy like this. So this retrieves the validation accuracy value for each epoch. So this was the training accuracy and this was the validation. So trained the model and then checked if the model is working fine, then we will get the accuracy from this. So for plotting the chart, this is simple plot that you can use by passing the directly this history object values. You can directly plot the chart. You don't have to go into too much detail. This is automated process, and as you know, X label, Y label, title and all those things you can easily write from the, I told you in matplotlib and seaborn sessions how you can use this. I have mentioned everything here also. So legend is as you know, you can write the legend like this in the chart so that it makes more sense to read. So this is for accuracy part, and this is for loss part. This is how you can get the values for loss. So this retrieves the training loss values for each epoch, retrieves the validation loss values for each epoch. So that was the accuracy and this is the loss, and rest of the I think parameters are almost same, but this time you are dealing with the loss values. So this plot helps you monitor whether the model's loss decreases over time. Ideally both the training and validation loss should decrease, but if the validation loss increases while training loss decreases, if the validation loss increases while the training loss decreases, it might indicate overfitting, and we will see this problem I think in this project I have mentioned. So this is the of course complete code that you can see, and these are the plots that it created. I have included these plots in this article that you can see, and also the details how to read this chart. I will continue this session in next video. See you in next video. Have a nice day.